G'day viewers, this is Troy from Troy's Visual Arts channel. I finally got my high powered motor rigged up with the disc spindle for my Nepkov disc for my mechanical TV camera. Yeah, I had to sort of go searching through my parts to see what I can find which could be usable for pulleys, and I'm using the old pulley from the previous disc for this mechanical TV camera for the motor, and I'm using a sewing machine switch, rotary switch as the pulley for the disc spindle, and it's friction driven by the belt. This camera's auto-focusing. I don't know what's happening here, but just give me a moment. I'll refocus. Good. Now, anyway, yeah. It drives it quite fine. The belt, even though the pulley's a little bit slanted, the belt doesn't fly off or anything, and yeah, that works all good. I've strategically positioned it so that it sort of friction drives it quite nicely without pulling the disc back. Anyway, on testing, it is all working, but I've ran into a high-powered problem, and that is for this motor runs off about 2.67 amps, calculating it by its resistance and its and the volts that it runs off. So yeah, it's 2.67 amps on its own. When I drive it on its own, it runs at about 2.67 amps, but when I'm driving this disc, it seems to require a lot more power to drive the disc to firstly overcome the inertia, and also to keep it maintaining at a decent speed. So I've been finding on testing that the resistor there smokes up from heat, and when I foolishly hooked it up to the speed control, it blew the arse out of the TIP31 high powered transistor. First I saw a lot of smoke, and then a kaboom, which was not cool. So yeah, I'm not too happy about that. And this morning I've just rigged up my analog multimeter to check the current that it's drawing to power this disc, and I've been finding it's at about 4 amps. Anyhow, I'll power it up and show you. So there it is. It's gathering up a bit of speed, and as you can see on the analog multimeter, it's drawing a bit over 4 amps. And this resistor is going to soon emit some smoke from heating up. I can start to see some smoke coming off it right now. And this is like a 20 watt resistor too, which is quite crazy. Anyway, powering it down for now. Let the resistor cool off a little bit. I'm going to then remove the belts and repower it up again, and you'll see that the current it draws is much lower. So stop the camera, and now I've got got the motor on its own and doesn't need to drive anything. Power it up. The current is a bit less than 2 amps. About 1.9 amps. Yeah, in case you didn't hear me, as seen on the multimeter, the amount of current the motor is drawing without having a load attached to it is a bit less than 2 amps, about 1.9 amps. So, and it was running, and this circuit was quite comfortably running the motor. and the TIP31 high power transistor was comfortably taking, you know, a bit under 2 amps, but yeah, it doesn't seem to take very kindly to 4 amps. It just blows the crap out of it. So yeah, what I'll have to do is either use a much higher powered transistor to take the current load, or find a alternate lower powered motor to drive the disc. Although the problem I'll be facing with that would be, will it drive the disc? Because yeah, this head drum is actually kind of heavy, and it does seem to need a bit of brute force to drive it properly. I did actually manage to get the disc to spin after the overcoming of inertia with my little DC motor over underneath these wires, which I used to drive the previous disc. It sort of started off very slow. I had to manually rotate it to get the momentum up a bit. But yeah, it did work alright. Although I'm not sure whether it spun up to NBTV standards. Anyhow, yeah, this motor just, well, it seems to require about 4 amps to drive this disc spindle. So yeah, I'll probably just look for a high powered BJT transistor to drive it and see how that goes. Also, I'm going to be, as it seems, I'm using two 10-watt resistors here to drive it, and they are bloody smoking up like all hell. So I think I probably need something like probably 40 watts worth of resistors to take the current load. So let me think, it's taking about 4 amps. Amount of the volts it's going for, it's roughly about 13 volts. 13 times 4, P equals VI. 13 times 4 equals 52. So I'm going to be needing about, so it's probably drawing about 52 watts of power to drive this camera. So I'm going to have to probably put about 5 of these resistors in parallel in order to easily take the load. Anyhow, that's the update for my mechanical TV camera. I am making progress, and hopefully I'll overcome this power problem and get all the circuits rigged up. I was actually meant to make a video of all this all rigged up ages ago, a few videos back, but hasn't come to that yet. But the circuits are mostly complete. Still yet to stick the chips in those. Yeah, going on to the other news on my camera about the circuitry. For this circuit here, I'm going to be driving straight from the power. I'm going to be driving the 12-volt regulator, and I've piggybacked the 5-volt regulator to the 12-volt regulator, so it saves me having to send out an extra wire to the 5-volt regulator, because, you know, 12-volt output, 12 volts DC, 12 volts input to the 5-volt, output 5 volts. Makes things a bit easier. And that 5-volt regulator will be powering the crystal clock, and it'll be powering this encoder circuit over here. So yeah, it saves a few wires. And this 10-volt regulator was variable regulator set to 10 volts. I'm either going to run it off straight from the main DC power supply, or I'm going to also piggyback that off the 12-volt regulator there. It's a bit of a decision, but actually I think maybe they could load down the 12-volt regulator a bit in doing so. I don't know, but it all depends how much current's required. I mean, I could run pretty much all this off the 12-volt regulator. and also got a 9-volt regulator for the LED driver as well. That may need. Actually, it's probably be better off if I just yeah, run the 9-volt and the 10-volt separately, so that way I'm not overloading the 12-volt regulator. But yeah, if I do it all separately, pretty much I'll just be needing 3 wires out, one to the 9-volt, one to the 12-volt, and one to the 10-volt. Anyway, the circuit's almost complete. Just got to, yeah, join up the power, the DC rails and the earth connections, and have the chipset circuit there. Got to join up that circuit with the BUZ71 MOSFET transistor, which is part of the speed control. So I've got output from about there to the gate of the MOSFET, and that's that part completed. Yeah, this also has got to run off separate power as well, because that's a lot of power's going to run through that for the main part of the speed control for the motor. Anyway, I'm going to have to go transistor hunting for a transistor that can take about 4 amps of current. Anyway, it's all getting there. I really hope to get this all rigged up soon, overcome that bloody motor power issue, and be all ready to go. So yeah, stay tuned for the next video. This is Troy from Troy's Visual Arts channel, signing out.